Welcome to you in the first lecture of abstract algebra. Group theory is one of the main topic in abstract algebra. Okay. Now we start what is group. What are the properties, what are the axioms under which a non-empty set G can make a group. Okay. So in order to define a group, first we have to need a non-empty set. So here I am taking a non-empty set and that set is G. Okay, and after taking a non-empty set, then what we will do? Okay, if I said let G be a non-empty set. Okay, non-empty set means that there exists some element, at least one element in G. Okay, so if there exists at least one element in G, if it is non-empty, okay, after that we take the first non-empty set, then a binary operation. Let star be a binary operation. Let star be a binary operation. Let star be a binary operation defined on G. Okay. Then we say that G is group. G is group if it satisfies the following four axioms under this star, under this binary operation. What are those four axioms? Okay, the first axiom is closure law. So what is closure law? The closure law is, it is just like for all A comma B belong to G, A steric B also belong to G. So this is called closure law. Okay. So if you see that the closure law is actually the binary operation. So what is binary operations? Binary operations is always defined on two numbers of any non-empty set. We take two numbers and any operations. Operations means that it may be addition, it may be multiplication. Here in group theory, operations are addition, multiplication, and we can take subtraction and even in some cases division. Only few cases. Okay. So here the first property is closure law. Remember that G is non-empty set and star is the binary operation. Then we say that G is the group if G satisfies the following four axioms under this binary operation. The first axiom is closure law. Okay, the closure law is actually the binary operation. Okay, so what is binary operations is always defined on two numbers. The first number, the two numbers are A and B, and we pick those numbers from G, and when we operate those numbers under the binary operation star, then it again belong to A steric B, or A star B also belong to G. This is the first property. Now we will move to the second property. The second property is associative law. Okay, for all A comma B comma C belong to G, A steric B steric C is equal to A steric B and steric C. Okay, so A, B, C are the elements of G. Yes, so this is you can say associative law. Okay, associative law, closure property, and the second property is associative law. Associative law. Okay, and the third property is identity element in G. So identity element, what does it mean by identity element? For all A belong to G, there exists an E belong to G such that A steric E is equal to E steric A. Okay, is A is equal to E steric A. Okay, so this is the identity element. Also we can say that it is identity element. Okay, the fourth property is for all A belong to G, there exists another element, and that element is A prime belong to G such that A steric A prime is equal to E, which is equal to A prime steric A. Okay, so A is an element of G, so there must exist another element in G such that when we operate that element under the binary operation star, either from the right side, either from the left side, we get the identity. So this A prime is called the inverse of G. Okay, it is inverse of G. Okay, identity and inverse. If these four axioms are satisfied in any non-empty set under this binary operation star, then we say that G is a group. So what are those properties? The first property is it is closure law. Closure law is actually the binary operations, which is always defined on two numbers. Okay, so it is defined on two numbers. We take any two elements of G, and under those binary operations the result again in G. Okay, and then is associative law. It is identity. What is identity? For any element in G, there must exist an element in G, and those element or such element is E. For all A belong to G, there exists an element E belong to G such that when we operate E on the right side or on the left side, our answer is the same. Okay, and this is inverse. So if these four properties are satisfied in any non-empty set under the binary operation, then we say that that set is called group. Hope you have understand about the definition of group. The group is actually defined on a non-empty set, star is the binary operation, and after that four properties: closure property, associative property, identity and inverse. Then G is called group. Okay, there is another type of group, and that group is called abelian group. So what is abelian group? Abelian group are those groups which satisfy the commutative law. Okay, abelian group. Here I am writing, that is the, you can say, fifth property of abelian group. What is an abelian group? Abelian group is for all A, B belong to G under the binary operation A steric B is equal to B steric A. Okay, so this is commutative law. Operation may be addition or multiplication. Okay, so operation here means that addition, multiplication, subtraction and division. Okay, so here you can see that if the fifth property is satisfied in any non-empty set under the binary operation, if this property is satisfied, means commutative law. If commutative law is satisfied in any non-empty set, then we can say that that non-empty set is an abelian group. Okay, now we take some example of group, and what are those example of group? Which are the sets, which are those non-empty sets that form the group?